I'm an engineer who study the mechanics of materials. In particular, I'm interested in biological materials, materials built by nature, and see if we can elucidate a better way to design engineering materials using clues from what we learn from these biological materials. Previous to our work, many biologists did work on the Mantis Shrimp that it could actually break shells. It's just we have a material that is tougher than the shell. We pay a lot of attention to shells, seashells. Now this material can actually break them. We open the material, especially the hammer, the ductile club of the Mantis Shrimp that hits at a given velocity. So they were able to actually see that and characterize that with microscopes. So once we have the geometry, then we start looking at, okay, how do we explain all this? And one thing that actually became clear is that the material is very brittle, but it has a lot of cracks, instead of having only one crack. When you have a very brittle material and you have, you have a high load, one crack will dominate. What we are observing in these natural materials is that the material has the capability to deform kind of elastically or plastically. That is why it's very, very hard to actually break this material, because it requires a huge amount of energy to deform it before it fractures. So that was a very important issue that we need to understand. So we look at fiber reinforced composites, like the ones that we use for cars, airplanes, aerospace structures. The composite industry know how to build laminates. What we need to do is try to actually understand how to build those things. Doesn't mean that we are replicating exactly how nature does it. We already have the technology to build laminate, right? So we know how to make composites. The work on the Mantis Shrimp, what it revealed is a different architecture, a different way to stack up different layers of the unidirectional fiber reinforced composites. The technology is there. What we are trying to implement with that is just a new layup, right? So the new design. It might take a little bit more of technology development, because now instead of doing 45 degrees, minus 45 degrees, 90 and 0, now we have to do some kind of helicoidal. But the technology is there. There is still a lot of work that we need to do. We know how nature, for that particular length scale, for that particular application, works with polysaccharides and minerals. I really hope that this can inspire many other people doing engineering and science, because nature can tell us a lot of things.